Hello everyone, welcome to this presentation. This time we are going to see how to connect a liquid crystal display to a Raspberry Pi. So in this video we will see first an introduction, then we will see the wiring, all the connections that we need to do between the Raspberry Pi and the LCD. Then we will see how to install the libraries that we need to use the LCD from the Raspberry Pi. And finally we will show a couple of examples to illustrate the use of the LCD. Here is the typical pinout of an LCD. We have a total of 16 pins here. Pin 1 is for the ground, pin 2 is the connection for the 5-volt power supply. Then we have pin 3, which is the pin used for adjusting the contrast of the LCD. Pin 4 is for the selection of the register. 0 is for sending a command and 1 is for sending data. Pin 5 is the read-write selection signal. Pin 6 is the enable signal, which is active by falling edge. And then we have the data signals from pin 7 to pin 14. We have the lines corresponding to the bits D0 to D7. And finally, in case that our display has a backlight LED, then we have pin 15, which corresponds to the anode of this LED, and pin 16, which corresponds to the cathode of this LED. Most of LCDs are based on this chip HD44780, which is a dot matrix LCD controller. This device can be controlled from a microcontroller or a microprocessor using a parallel connection of 8 or 4 bits. Here we can see the schematic corresponding to the chip with all the connections and blocks inside, and on the right we can see the pin arrangement for the device. This chip can be used in two types of LCDs. It can drive LCDs with a total of 40 dots, in which the characters are formed with 5 columns and 8 rows. And it is possible also to use this chip to drive LCDs with a total of 50 dots in a configuration with 5 columns and 10 rows. And finally, the chip also incorporates two maps of characters. One is the A00 map that we can see all the characters here on the left, and then we have the A02 map with the characters shown here on the right. So with this we can go ahead and see the connections that we have to do in order to wire the Raspberry Pi and the LCD. So we can see that it is pretty straightforward to do the connections. Just the ground goes to pin 6 of the Raspberry Pi, the 5 volts power supply go to pin 2 of the Raspberry Pi. Then we can connect a potentiometer here in order to adjust the contrast of the LCD, or we can just use two resistors in series to generate the desired voltage. Then we can connect the other pins to the available pins that we have in the Raspberry Pi. It is not really important what pin we are going to use for each of the digital signals, as long it is a pin corresponding to a general input-output signal of the Raspberry Pi. So here we have selected the pin 15 to connect to the register, then pin 18 to connect to the read-write signal, pin 16 is connected to enable, and then we are using a 4-bit communication to simplify the wiring. So in this case we are using pins from the Raspberry Pi 21, 22, 23 and 24 connected to the pins corresponding to D4, D5, D6 and D7. And finally, in the case that our LCD has a backlight LED here, then we can connect the anode and the cathode to the power supply using a 100 ohm resistance from pin 2, and then the cathode is connected directly to ground. You can see here in these pictures how I did the connections. Here we can see the connections from one side, and here on the right the connection from the other side. I added here a potentiometer in order to be able to adjust the contrast of the screen. So let's see now how to install the required software that we need to drive the LCD. Basically, we need two packages, the library RPI.GPIO. Probably we will have this installed in our Raspberry Pi already. And the other one is the RPLCD, which is necessary also to drive the LCD. So let's see how to do this. I'm going to open a secure cell connection with my Raspberry Pi at 192.168.1 and 73. So I type in the password and hopefully we will be connected to the Raspberry Pi. So the first thing that we need to do is to install, if we don't have it yet in our system, the PIP installer. So we are going to do it sudo apt get install python 3 PIP. Okay, so in this case it is said that we have the newest version of PIP for Python 3, so we can go ahead and do the installation of the RPI GPIO. So we do sudo pip 3 install rpi.gpio. Probably I have this already in my system. So we can see that this requirement is already satisfied, so we can go ahead and install the RPLCD library. So now we have it ready, installed in our system. A couple of interesting commands that we can show here is if we want to see all the packages that we have installed using apt-get, then we can use this command here. So let's hit apt list installed. So we can see here all the packages that we have available, and also the packages that we have installed using PIP. Then we can see them doing PIP3 list. So we can see here the packages, and especially the two packages that we need. These libraries RPI and GPIO and RPLCD are ready, so we can now go ahead and use our LCD. It is also interesting to know how to remove packages. So if we want to remove a package installed with apt-get, and then we can use this command here. And for removing packages installed with PIP, then we can use this other command shown here. Let's see now an example on how to use the LCD library. It is very easy. We only have to import the command char LCD from the library rplcd.gpio, and then also import the function gpio from rpi library. So we can set the warnings of the GPIO to false, but this is not mandatory. And then we create the function LCD by doing like this, char LCD, and provide the different parameters, the basic parameters that we need for our LCD. Here, numbering mode means that we are going to use directly the pins from the board, the number of the pins of the Raspberry board instead of the channels. And here in the rest we are saying what is the number of the different pins, the register select and the read write, the enable, and the pins corresponding to the data, as we have seen in the schematic before. Here we are providing information about the cores, the columns that we have in our LCD, the number of the rows, the dot size, in this case 8, and the chart map that we are going to use. Also, it is interesting this other option here, auto line breaks equal to true, because in this case the printing is going to do automatically the breaking of the lines. And then in order to print a string, we only have to do like this, lcd dot write string, and then the string that we want to print. So with this we can execute our program doing like this, python 3 lcd test dot py, and then this is what we are going to get in the LCD. Here I am showing other commands that we can use to drive the LCD and that are interesting. For example, to clear the screen, to write strings. We can also use special characters in our string, how to locate the cursor at a given position, also close the communication and clear the LCD, send a raw command directly to the LCD. This one is to create a new character. We will talk about this later. Send a carriage return character, also write a line feed and carrier return directly with these commands here. Set the cursor to the initial position, shift the display a positive or a negative amount in the screen, and also another command for the alignment of the text. Another interesting possibility of these LCDs is that we can create up to 8 new characters that can be stored in the RAM memory of the chip. For this we use this function here, lcd create character, and then we provide the location in RAM memory. So this is a number between 0 and 7, and then the bitmap with the drawing corresponding to our new character, and this is provided by giving a tuple of 8 numbers of 5 bits that are going to represent the 40 pixels of the character. So that in each bit corresponding to these numbers, if the value is equal to 1, then this dot is going to be on, and if the value is 0, then this dot is going to be off. So here is an example. We are creating here a smiley character. So we have here the corresponding definition, and then we create the character in the position 0 of the RAM, and then we can just print on the screen the new character by using backslash and the number corresponding to our new character. Here we have an example on how to use this. The program is the same as before. We are only adding the definition of the smiley and the creation of the smiley. So we can just do the printing on the screen by adding backslash and the number 0 corresponding to the position of our new character. Then if we execute the program and doing like this, then we can see the smiley face on the screen. Finally, in order to get the full information about the different functions of the RPLCD library, I recommend you to visit this link here. Okay, this is all today in this presentation. Thank you very much for watching. Please let me know if you have any comment or question, and I hope to see you in the next video. Goodbye now.